It's time for Orchard Skills. To develop an Internet of Things solution, you'll need the hardware and software components that integrate together with the connectivity and make the devices exchange data. Each hardware component, like the sensors and actuators, are designed for a particular task and purpose. So we'll need to determine which hardware to use for developing our Internet of Things project. Today on Orchard Skills, we'll be creating the Hello World Internet of Things devices. We'll use the infamous Raspberry Pi 30-pin header along with the general purpose inputs and outputs, GPIO, to interface with our device, which will be a simple LED and a resistor. Please stay with us and we'll get started. Welcome back. In a previous video, we set up a Raspberry Pi development environment. Please check out that video to set up your environment. Instead of using Orchard Core, let's start out simple and create an ASP.NET 5 web application. Besides, I want to utilize the latest .NET release. It was released back in November 2020. Instead of creating everything from scratch, let's take advantage of all the work the .NET Internet of Things community has created. We'll be using .NET Iot Libraries. It's located at https://github.com/.net/IoT. This library contains the system.device.gpio library and implementations of various boards like the Raspberry Pi. The repository also contains IoT device.bindings, a growing set of community-maintained device bindings for IoT components. I believe the best way to learn these libraries is to start out by using them. So let's get started. In order to create our IoT device, we will need a Raspberry Pi, a breadboard, a LED, a 330 ohm resistor, and jumper wires. You must always use resistors to connect LEDs up to the general purpose I/O pins of the Raspberry Pi. The Raspberry Pi can only supply a small current, about 60 milliamps. The LEDs will want to draw more, and if allowed to, they will burn out the Raspberry Pi. Therefore, putting a resistor in the circuit will ensure that only a small amount of current will flow and the Raspberry Pi will not be damaged. Resistors are a way of limiting the amount of electricity going through a circuit. Specifically, they limit the amount of current that is allowed to flow. When you pick up an LED, you will notice that one leg is longer than the other. The longer leg, known as the anode, is always connected to the positive supply of the circuit. The shorter leg, known as the cathode, is connected to the negative side of the power supply, known as ground. LED stands for light emitting diode and glows when electricity is passed through it. LEDs will only work if power is supplied the correct way, if the polarity is correct. You will not break the LEDs if you connect them the wrong way. They will just not light. If you find that they do not light in your circuit, it may be because they have been connected the wrong way. Let's launch Visual Studio. Okay, great. Let's go ahead and create a new project. And let's select an ASP.NET Core web application. And for the project name, let's go ahead and do orchardskills.raspberrypi.led on off. Go ahead and click on Create, and we'll use a Model View Controller. Make sure we have ASP.NET Core 5.0, and we don't need any authorization, and we don't need Docker support. And let's go ahead and hit the Create button. Okay, great, we got our application. One of the first tasks is to create an LED device. So let's right-click and click on Add. Let's add a new folder, and we'll call this Devices. And inside devices here, we'll add a new item, and let's call it a class, and let's call the class LED device, and click on add. All right, great, we have a device. So this device is going to be utilizing the system.device.gpio. Let's go ahead and add that NuGet package to our project. So let's click on our project, right click, and say Manage NuGet Packages, and let's go to Browse, and let's search for system.device.gpio, and there it is right there, version 1.3. Let's click on that, hit the Install button, and say OK, and I accept. Okay, great. That's all added to our project. And so to make sure, we notice here it added a package reference of system.device.gpio. So let's go back to our device here and let's add a reference to system.device.gpio. Inherit iDisposable. Let's go and do that. Of course, when we do that, we have to have the method. So let's create that. So in iDisposable, we're going to have to utilize the GPIO controller. Add a reference to that. We'll just call it controller. And also we want to specify a pin. So let's do that as well. So we use LED pin 17. Okay, we'll also want to create a constructor. So let's do public LED device. And in the constructor, we want to create a new controller, which will say new GPI controller. And in the controller, we want to open a pin, which will be our LED pin, which is 17. And then we want to do pin mode of output. And then let's write and set that pin low. Okay, great. Now let's add some methods here. Let's do a method LED on, another method LED off. Okay, so for LED on, all we need to do is basically do a controller write LED pin value of high. And then if for LED off, we want to do controller write LED pin value low. Okay, great. We have everything all completed. We want to be able to get information from our LED driver class, and so create a couple of properties. And the two properties I want to create are public bool is LED supported. Because if we run this in an environment like under Windows that doesn't have a general purpose I/O in the operating system, then we're going to get an exception. So if we do, we want to set this property to false. Also, we want to determine if the LED is on. So we'll say is LED on, and then we have a getter and setter, but the setters are going to be private. So we want to make sure that. So now in our LED device, in our constructor, let's wrap this in an exception, right? That's always good. So let's do that. Put that in a try block, and we'll do a catch. In our catch, we want to catch system not supported exception. Add our curly braces, and in there, let's create a boolean here, LED supported, and we'll just assume it's true here. And down here, if it's not, we want to LED supported equals false, and then we just want to console write line e.message to output that to the console log. And so let's also add a finally here, and in the finally, let's add our property to LED supported. And for our dispose, let's create a protected virtual void dispose, and we'll set the dispose value to false initially. Let's go ahead and do that, declare that. And so for our dispose method, what we want to do is to call dispose with true. So that means it's disposing. So if not, dispose value, and if disposing, then we will go ahead and dispose the controller. And then we set our dispose value to true to safeguard that. Another thing we want to do is to safeguard is on our LED on and off, let's create a lock object there. So if in case someone visits our website, two people are clicking on the buttons, then we want to lock those buttons up. We don't want them to simultaneously click something and get out of whack here. So let's declare a locker object, and then in our lock on, what we want to do, lock the object. If LED supported, do the controller.write, and then we say is LED on, is it true? So we set the property. And for LED off, we want to do the same, but in there we want to do pin low. Okay, great. I think we got everything all done. Let's go to our home and go to our index. And let's replace this to a view bag. If it's on, then we want to display an image of our light being on. Otherwise, if the equal false, then we do false. And also here, we want to kind of make a nice dark background, and then we want to justify using Bootstrap, print out if the device is supported, the status of the LED. And then also we want two buttons to turn the LED on and turn the LED off. Let's go to the home controller. And for the logger, let's make this simple and let's not implement logging here. So let's delete that. So include our Orchard Skills, Raspberry Pi, LED on-off devices. Let's do a private. Go ahead and declare our device, which will be an LED. Put that here. Okay, and then let's pass them through here. Inject that. And then we'll go ahead and set that. And so for the index, is set up the bag is supported, yes or no. And then LED state, on or off. Then we also want to do two actions, LED on, which we'll call the LED on function. And we do redirect to the index, and also for the LED off, redirect to the index. And let's go to the view imports. And we'll also want to add our devices there. Now let's go to our startup.cs, remove these that we don't need, and we're going to need our devices here because inside of our configure services, we want to add singleton for that device. Okay, great. I think everything's all completed and ready. Let's save everything. Let's go up here and rebuild solution, and let's go ahead and run. Okay, great. So now you see that we're running on our PC, so the LED is not supported, but we have buttons to turn on, and then we get a nice glowy bulb when we turn it on, and then we do off, on, off. Okay, let's install this on a Raspberry Pi and see if it works. Okay, so here we turn it enable, turn on, LEDs on, LEDs off, LEDs on, LEDs off. Now to recap, we created an IoT device from a Raspberry Pi, a breadboard, a LED, a 330 ohm resistor, and jumper wires. We built an ASP.NET 5 web application that contained the LED status and two buttons to turn the LED on and off. And we ran the application on a Raspberry Pi, turning an actual LED on and off. Now, if you missed or didn't understand something, that's okay. There's a detailed blog post that describes all the steps. There is also a GitHub repository with the complete source code. All this information is in the video description. If you like this video, please click on the thumbs up icon. Also, please subscribe and click on the bell icon to get a notification when I release the next video. Thank you for watching.